A very warm welcome to Syllabus Orientation Workshop. Syllabus Orientation Workshop for second year Civil Engineering 2019 pattern, organized by Sinhgad College of Engineering, Pune, in association with Board of Studies, Civil Engineering, Savitribai Phule University. I once again welcome you all on the behalf of Host Institute and all my organizing team. Today, we will be having the privilege to listen to experts from the geology. We are very fortunate to have very iconic personalities from the field of geology to share their experiences. Today, we will be having two morning sessions and one afternoon post-lunch session, addressing the orientation for first 3 units of engineering geology. We have the great group of enthusiastic, more than 100 faculty participants representing over 70 institutes. It's my request to all the participants to follow the guidelines which are delivered on the group. So, shall we start, sir?
Yes. Yes,
Yeah.
sir.
With the permission of the chair and the subject chairman, let's begin with our session. Now, our first session will be on Unit 1, General Geology, Mineralogy, and the Petrology. The topic learning objectives are to know the basic concept of engineering geology, the physical properties of minerals, and to differentiate between rock types, knowing their inherent characteristics for civil engineering applications. So let's open the book called Geology with its unique vocabulary and different set of alphabets. I welcome our first speaker of the session, Dr. A.J. Shirke sir. I take this privilege to introduce him. Welcome, sir.
Thank you.
Dr. A.J.
Welcome.
Shirke has completed his BSc Geology, MSc in Geochemistry with Junior Research Fellowship. He has completed his doctorate in Geochemistry in year 1996 from Shivaji University, Kolhapur. He is presently working at Dr. Vittal Rao Vikhe Patil College of Engineering, Ahmednagar. He has a total teaching and administrative experience of 24 years at various prestigious academic institutions. He, he has a research experience of more than 4 years. He also has 6 minor and major research projects to his credit. He has 46 research publications at international and national journals, 54 published papers at various conferences. He himself has organized more than 20 conferences and workshops. He is a recipient of Best Book Writing Award by UGC New Delhi for his book on communication skill. I hand over the proceedings to our speaker for the beginning of the session. Welcome, sir.
Thank you. Thank you. Welcome to one and all. Respected Chairman, Dr. Londe sir, BOS Civil Engineering, SPPU Pune, Coordinator Professor Dr. Shastri sir, and all the organizing committee member of this workshop. Good morning and welcome to all the participants of this workshop. I, Dr. Sirke AJ, take permission of organizing committee to start the lectures.
Go ahead, sir.
Savitribai Phule University.
Savitribai Phule. एकच मिनिट, व्हिडिओ ऑन करता का जरा थोडा वेळ, जर बँडविड्थचा इश्यू नसेल तर फॉर सम टाइम.
ओके सर.
आपल्याला ऑनलाईन फोटोज पण घ्यायचे असतात ना स्पीकर आणि यांचे, म्हणून.
हा, बरोबर.
हा, येस. थँक्यू सर.
ओके सर. Savitribai Phule Pune University Syllabus Orientation Workshop for SC Civil Engineering 2019. Subject Engineering Geology, Unit 1, General Geology, Mineralogy and Petrology. Next slide, sir. Engineering Geology, the course of Engineering Geology, it is for the credit marks is 3 plus 1. The teaching scheme, lectures 3 hours per week, practicals 2 hours per week. Examination scheme for this subject, in semester exam 30 marks, in semester exam for 70 marks, and here point is noted, the term work is 25 marks. Up to the last year, for this subject, the term work marks is 50, and here to reduce the term work marks of 25 marks. Next, course objective of this subject, to get the knowledge of physical properties of the mineral and differentiate between the rock, their inherent characteristics with the civil engineering applications. Second, to learn geomorphological features formed by fuel marine processes and their role in civil engineering projects. To comprehend the structural geology applied to the engineering projects, and to get the idea about the plate tectonics for better development of the civil engineering projects. To acquire and apply the knowledge of PGE essential for civil engineering projects. To identify and to enable the students to examine the favorable, unfavorable condition for the proposed construction of the dams, reservoirs, tunnels, etc. in civil engineering. Last, to learn the role played by the effects of groundwater, geological hazards, and their requirement and utility of a good building stone in civil engineering. Next, the course outcomes of the subject. After successful completion of the course, the student will able to understand and explain about the basic concept of the engineering geology, various types of rocks and their minerals, both in the laboratories and on the field, and their uses in civil engineering constructions. Second outcome, the student will able to exploring the importance of mass wasting processes and various tectonic processes and its implementation on environment and sustainability. Third, student will able to recognize the effects of plate tectonic structural geology and their significance and utility in civil engineering activities, those which has been carried out day by day. The student will able to incorporate the various methods of survey to evaluate and inherent geological natures of the rocks present in the foundational of the dams, percolation tanks, tunnels, etc. Then fifth, to assess the importance of geological nature of the site in different types of civil engineering projects. And last, the student will able to understand and explain the geological hazards, their importance, the importance of the groundwater, and use of the different types of a building stone for completion of the civil engineering project at various types of the area. Next, this is the syllabus of the civil engineering. This is the syllabus of the engineering geology. As per my knowledge, in this syllabus, one major changes has been carried out. That is the unit number second. In last syllabus, the unit number second is structural geology and plate tectonics. But here you have to observe that the unit number second is geomorphology and historical geology. Unit number third is structural geology and plate tectonics. And unit number four, remote sensing and GIS and preliminary geological studies. Unit number fifth, role of civil engineering in dams, reservoirs, and tunneling. Unit number six, geological hazards, groundwater, and building stones. Next, practical works or a term works in engineering geology. First, the megascopic identification of the different types of minerals, that is the rock forming minerals, ore forming minerals, and economical important minerals. This is required for better understanding of the minerals and their formations with respect to their significance, with respect to their origin for the formation of different types of rocks, and for completion of different types of civil engineering projects and better development of the civil engineering project to the fields. Then in second practical, megascopic identification of different types of a rock specimen in the laboratories, that is the different types of a rocks. Why we will identify the rocks? Because the rocks are directly concerned with the civil engineering project. Their presence and absent, different types of minerals, how they can be affected to the rock and their formations is one of the most important things. The rocks are identified with the help of essential group of the minerals as well as the accessory group of the minerals, and that's why the rock bodies are identified in different civil engineering projects areas, those which has been directly indirectly affected by their formations and their origin in different civil engineering projects. That is igneous rocks, sedimentary rocks, metamorphic rocks. These are the most important rocks. It is directly concerned with the civil engineering projects. It has been affected to the civil engineering project directly, indirectly, after the construction, or before the construction, and that's why the essential, it is required the knowledge about identification is essential for civil engineering students. Then interpretation, interpretation and construction of geological section from the contoured geological maps. Here, AG series, AG Gupta series has been used. From this, total 8 maps are prepared and 2 maps to constructed by the faculty members. In fourth, solution of engineering geological problems such as alignment of the dams, tunnels, roads, canals, bridges, etc. based on the geological maps. Fifth, logging of drill cores, interpretation of drilling data with the graphical representation of the core lab. It is very important. Then for this subject, 2 site visits are desirable to study the various types of rocks, geological features, geographical features in the nature. Next, in engineering geology, first the unit number first, it is general geology, mineralogy, and petrology. This unit is divided into three parts. That is the introduction to the subject, their scopes and subdivisions. Second, introduction to the mineralogy, physical properties of the mineral, classification of the mineral. Then third part, that is the introduction to the petrology and broad classification of the rocks. In this, three major rock formations are studied because the student will able to understand by the meaning of the minerals, how the minerals are formed in the nature, how the rock bodies is formed because the rock is made up aggregation of the minerals. It is the aggregates of the minerals. Therefore, the study of rock is essential. It is required, and that's why here we will study the different types of a rocks. That is the igneous rocks, sedimentary rocks, and metamorphic rocks. Then here the course objectives. Next, next, next. Course objective for particular unit number first, to get the knowledge of physical properties of the mineral and differentiate between the rocks types, their inheritance characteristics with the civil engineering applications. Here we will study the different types of physical properties of the minerals for identification of different types of rocks and their formations. The course outcomes of these particular units, that is student will able to explain about the basic concept of engineering geology, various types of rocks and mineral both in the lab, on the field, and their inheritance characteristics and their uses in civil engineering constructions. Next. Prerequisite for the unit number first, geology, geography, geochemistry of the school, and higher secondary education of this syllabus. Post requisite for unit number first for civil engineering course, for this course. This unit will be helpful for construction, helpful for concrete technology, building material, dams and hydraulic structures, construction management, advanced engineering geology and rock mechanics, etc. Next. Here the lecture plan for these subjects. For this subject, uh, as per university curriculum, the university has granted 7 lectures for this unit, but 7 lectures are not within a 7 lectures. We cannot teach this unit. For this unit, we required extra lectures, and that's why here, as per curriculum, the teaching plan has been prepared. In first lecture, we will teach the introduction of the subject, scope and division of the subject, then interior of the earth and internal structure of the earth, mineralogy, igneous petrology, sedimentology or sedimentary rocks, metamorphic rocks. Because next, next, the students of the second year civil engineering able to understand the syllabus of the engineering geology and clear the concept of engineering geology for better development of the civil engineering project to the surface, to the subsurface of the earth. That's why the geology is most important subject in civil engineering and their applications in the civil engineering, because geology, you know, each and everyone has to know about the geology. Geology, it is a Greek word. Geo means earth, logos means science. That's why geology is the study of the earth, and the earth has evolved, it is changed throughout its history, and will continue to evolve, and therefore the study of geology is essential. It is required for better understanding of the different types of concept in civil engineering applications. And you know, the human being have the capability to make the rapid changes. All the constructions from the houses to roads to dams are affected by the earth, and and thus it requires geological knowledge about their effects, about their formations, etc. Then about the internal structure of the earth. Here, the earth has layered structures. Layering can be viewed into two different ways. That is, first, layers of the different chemical composition, or on the basis of chemical composition. Layering has been divided into three parts. That is the crust, mantle, and core. Crust, there are two types of a bodies, that is the continental crust and oceanic crust. The thickness of the continental crust below the continents is 10 to 70 meter thick. It is made up of granitic rocks. Oceanic crust 2 to 10 kilometer in thick, made up of basaltic rocks. Mantle, the thickness of the mantle is 3,488 kilometers. Core, it is the innermost part of the earth. Next, this is the interior of the earth, or internal structure of the earth. That is, here you will see the layering of physical, on the basis of layering of physical properties of the rock, and layering of chemical composition. First, the layering of physical properties, or layering by physical properties, that is lithosphere, asthenosphere, hydrosphere, then atmosphere. Here, on the basis of compositional pattern, the earth is divided into three parts, that is the crust, mantle, and core. Next, this is the subdivisions of the engineering geology, or major subdivisions of engineering geology. First, physical geology, geomorphology, which deals this study of the different types of a shape, size, and different types of a feature, those which has been present to the surface of the earth. Then mineralogy, which deals the study of the minerals. Petrology, which deals the study of the rock bodies. Then structural geology, which deals the study of the structure of different types of rock formations. Then stratigraphy, which deals the study of the layers, beds, and their formations to the surface, to the subsurface of the earth. Then paleontology, which deals the study of the fossils. Hydrology, which deals the study of superficial, subsurficial water, which gives the lots of information about the water. Economic geology, which deals the study of the economically importance of the minerals. Then allied sciences, that is geochemistry, geophysics, geohydrology, mining geology, engineering geology, rock mechanics, which deals the study of the behavior of the rocks, etc. Next, third topic. Next, sir. Scope of engineering geology in civil engineering is the most important thing. In construction of jobs, engineering geology gives the information about the different types of a rocks in all types of a heavy constructions, like building, towers, dams, reservoirs, highways, bridges, traffic, and hydropower tunnels and retaining structures. This information is vital for the planning and designing an economic excavation of one and all such projects. In planning, it provides the information about the geomorphology, groundwater conditions for better development of the projects and their planning and their development to the surface, to the subsurface of the earth. Designing the for the designing
Hello,
the
sir. Voice is not audible.
hello hello आता येतोय का hello designing hello
Yes, sir. You are audible now.
okay in designing the existence of the hard rock bodies and their depth from an different excavations, their their resistance to the decay and disintegrations, and presence of structurally weak planes, just like joints, fault, fractures, weak stones, especially at the critical region at the site of selected for the projects. Next, sir. In town planning and regional planning, the major factor of the town planning, the allocation of the site for industrial site, it depends upon the geomorphology of that area. If the geomorphological area or geological area is disturbed by the town planning or by the development of the sir slide हे झाले hello for development of the different industrial phase. For the purpose of that, you know about the knowledge about the geomorphology, geology. It is essential for better development of these projects. Then in water resources, exploration and development of the water resources have become very important areas of the activity for the scientists, technologists, and engineers of all parts of the world. The water bearing properties of the rock bodies and their storage, movement, and yield of water of different aquifers. And it is essential, it is required for better development of the civil engineering projects. Next. Mineralogy. In mineralogy, here we will teach the definition of the mineral, physical properties of the minerals. In definition and origin of the minerals, everyone has to know about the definition of the mineral. Mineral, it has a naturally occurring solid homogeneous substance. It has a definite chemical composition, definite atomic structure, and formed by inorganic processes in nature. That is called as a minerals. For the better understanding of the students of the SC Civil Engineering, here we will prepare the different types of slides, photographs of the different types of minerals for better understanding of the meaning of minerals. If the student will identify or student will understood what is meant by mineral, then they will be able to understood what is meant by rock, because the rock is a aggregates of the mineral. Therefore, the study of mineral is essential. It is required for the civil engineering students, and that's why here the concept of mineralogy is clearly understood by the students. If it has been understood by the student, then they know about the rocks, their formation and their origin, and how they can be identified with the help of mineralogy. Because the minerals are two types of a minerals, that is the rock forming minerals and ore forming minerals. Rock forming minerals, there are rock forming minerals which define the rock, which gives the name to the any types of a rock body. Therefore, if you know, if the student will know about the mineral, then he is define the different types of a rock body to the nature, to the laboratories, or and on the field of. Then rock forming minerals are again divided into two groups, that is the primary minerals, secondary minerals. Primary minerals, it is directly concerned with the magmas or lavas, because the primary minerals are made up directly from crystallization of the magmas or a lavas, and that's why the study of primary mineral it is essential, it is required. Because in the primary mineral there are two types of a minerals, that is the essential minerals and accessory minerals. Why we will study the essential minerals? Because the essential minerals is the abundance of the rocks which directly define the rocks, which directly with the help of abundance of the minerals we will identify any types of a rock bodies. It should be igneous, it should be sedimentary, or it should be metamorphic. And that's why the essential group of the minerals and accessory group, knowledge about the essential group of the minerals, accessory group of the minerals, it is required for better understand better understanding of the students to the identify of different types of rocks in the nature. Then ore forming minerals, it has a economical values. All the economy of the society which which depends upon the natural resources, which depends upon the economical valuable minerals related to the different areas, related to the different types of a work. And that's why for better development of the civil engineering project as well as their sustainability development to the earth surface or to the subsurface of the earth, you know about the economical valuable minerals, you know about the ore minerals. If it is occur in that area, then that area should be avoided, because it has a economical value, it is directly affected by the environment, it is directly affected by any types of a gases, or it is directly affected by the water. And that's why that area should be avoided for better development of the civil engineering project and their sustainability to that area. Therefore, we will study here, we will study the ore forming minerals and their identifications. Then classification and their classification. Then about the physical properties of the mineral. The physical properties of the mineral is most important properties to identify any types of minerals in nature to the field of civil engineering. Because if once the student know about the mineral, then he should identify any types of a rocks, he should investigate any types of a rocks and how the rock is affected to the civil engineering projects. That's why the physical properties of the mineral is one of the most important properties of the mineral to for identification of the minerals and better development of the civil engineering project. related to different types of areas in civil engineering and their applications. Next. Then about the petrology. Petrology, petro means rock and logos means science. It is the rock science. It deals with the study of the rocks. And that's why the rocks, it is the aggregates of the minerals. Therefore, the major rock formation, study of major rock formations is essential. It is required for the completion of different types of civil engineering projects, for better development of the civil engineering project to the surface, to the surface of the earth. In this, there are three major types of rocks, that is the igneous rocks, sedimentary rocks, and metamorphic rocks. In igneous rocks, why it is we will study the igneous rocks? Because in the state of Maharashtra, or the majority part of Maharashtra, about 85% of area of Maharashtra which was covered by igneous rock bodies. In this area, major rock formation is Deccan Trap basalt, and that's why the study of igneous rock body is required. It is essential to the second year civil engineering students. Basic nature about the basalt, basic concept and their formations about the igneous rock is required to the students, and that's why here we will study the igneous rocks. Igneous rock, those which those rocks which has been formed by cooling, solidification, and crystallization of the magmas or lavas to the surface and subsurface of the earth. And that's why the classification of the igneous rock is required. The igneous rocks which has been classified on the basis of the silica percentage, on the basis of their origin, on the basis of their silica saturations, that is nothing but the plutonic rock, hypobasal rock, volcanic rocks. Volcanic rocks, it is directly formed by crystallization of the lava. Plutonic rocks and hypobasal rocks, it is directly formed by crystallization of the magmas to the subsurface of the earth. And that's why these rocks, how they can be formed to the surface to subsurface of the earth, it is required for better understood of the students. Then structure and texture of the igneous rock body. Actually, the texture of igneous rock body is required for better development of the civil engineering project to the surface of the earth, because the structure and texture of the texture of the igneous rock body is directly affected to the civil engineering projects. And that's why here we will study the different types of structures, texture of the igneous rocks, and we have to find out their engineering significance according to the civil engineering projects to the surface, to the subsurface of the earth. In igneous rocks, next sir, next slide sir. Here the igneous rocks which has been formed by cooling and solidification of the magmas, that is called as the igneous rock. There are some types of igneous rocks. Next sir. Next. Here you have to observe that the igneous rocks which has been classified on the basis of their texture, that is coarse grain, fine grain, porphyritic texture, then clastic, glassy texture, vesicular texture, pyroclastic texture, coarse grain textures. The which shows by pheneric rocks. Those rocks which has been identified with the naked eye is called as a pheneric rock. Apenitic rocks, those rocks which cannot, the mineral composition and their formation cannot be identified with the naked eye, that is called as pheneric rock, apenitic rock. And that's why here there are three types of a rock, that is the coarse grain, fine grain and medium grain igneous rock bodies. Their texture is one of the most important factor. Then porphyritic texture. Porphyritic texture, if the phenocryst is surrounded by the ground mass, is called as a porphyritic texture. If the porphyritic texture is obtained by any type of igneous rock body, then that rock is used as a ornamental stone after the polishing. And that's why the nature of the porphyritic texture is essential, it is required. Then glassy texture, vesicular texture, then pyroclastic texture. These are the some textures of the igneous rock body. Next sir, is the vesicular texture. If the vesicles are empty after the formation of the Deccan Trap basalt, that is the vesicular structure. Then then porphyritic structure, pyroclastic structure. Next, sedimentary rocks or sedimentary petrology. Sedimentary rocks, you know, the sedimentary rocks which has been formed by consolidation, cementation and recrystallization of the sediments. And that's why how the sediments are formed to the surface, to the subsurface of the earth, and the knowledge about the sediments is essential, it is required. And that's why here we will study the different types of processes which has been directly affected to the formation of the sedimentary rocks, that is first of all weathering and erosion. In the formation of process of sedimentary rock, there are three types of processes which has been involved, that is weathering and erosion, sedimentation, lithification and diagenesis. In the process of weathering and erosion, in the process of weathering, the sediments are formed because the sediments are pre-existing products of the weathering. In the process of weathering, there are two types of processes which has been involved, that is the process of disintegration, process of decomposition. And that's why the sediments which has been formed to the surface of the earth, and after the formation of the sediment, that sediments which has been affected by the natural agencies, and that has been transported from one place to the another place, get deposited according to their sizes, and that process is called as a sedimentation. After the process of sedimentation, there is a process of lithification and diagenesis. In the process of lithification, the soft rock is converted into the hard or frame rocks, is called as a process of lithification. In the process of lithification, there is a diagenetic change, that is the physical and chemical changes which has been occurred due to the process of decomposition. Once the sediments which has been formed, then it has been comes in a contact of water, then automatically it is affected by the water, it has been decomposed, and according to their sizes, according to their decomposition, it is deposited in the form of layers, in the form of a beds. Then that rock body is called as a sedimentary rocks. Why will take this syllabus? Because the student will not anything about the formation of the sedimentary rocks. They know about only the sediment rocks, but they cannot, or they did not know about the formation of any types of a sediment rocks and their effects to the civil engineering projects. Because the sedimentary rocks are used as a ornamental stone as well as it is used as a construction material at various areas. Then in the process of sedimentation, in the process of formation of sedimentation or sedimentary rocks, after that the we will identify the different types of sedimentary rocks with the help of their characteristics and their engineering significance. Next. Sedimentary rocks. This is the process of formation of the sedimentary rocks. That is the weathering. In the process of weathering, that is the process of disintegration, process of decomposition, how the sedimentation process which has been involved, it is affected to the surface, to the subsurface of the rocks. These are the some rocks, those which has been classified on the basis of clastic and non-clastic sediments. According to the clastic sediments and non-clastic sediments, the rocks are formed in sedimentary origin, that is the conglomerate, breccia, then sandstone, shale. These are formed by non-clastic sediments. Then next, these are the another sedimentary rocks, that is the fossiliferous rocks, that is the shale in with plant fossils. Then photographs of the dinosaurs fossil. Next, sir. Metamorphic rocks. Metamorphic rock. Meta means change. Morphe means shape, size, and their orientation of the mineral, which has been affected due to the temperature, pressure, and chemical active solvent. If any types of a rocks comes in a contact of temperature, pressure, and chemical active solvent, then it has been affected to that natural agencies and to form the rock. That rock is called as a metamorphic rocks. Any types of a rocks, it may be sediment rocks, it may be igneous rock, or it may be metamorphic rocks. Whenever it comes in a contact of temperature, pressure, as well as chemical active fluid, then that rock body is called as a metamorphic rocks. Then next, sir, this is the granite. How the granite which has been formed in the granitic gneiss. Metamorphic rocks which has been formed due to the effects of the metamorphic agents, that is the temperature, pressure, and chemical active solvent. And that's why the granite, whenever comes in a contact of temperature, pressure, and chemical active solvent, then it has been metamorphosed to form granite gneiss. Actually, granite gneiss is used as an ornamental stone, and that's why the knowledge about the granite is required to the civil engineering students and their formations. Next, sir. Next, then whenever the cell is comes in a contact of metamorphism, then it is converted into the slate. Again, it is slate is used as a flooring material. Then sandstone. Whenever sandstone is comes in a contact of thermal metamorphism as well as dynamothermal metamorphism, then it is converted into the quartzite. Sandstone, it is used as a building stone. Quartzite, again, it is used as a building stone, just like a conglomerate, then quartzite. These are the used as a building stone at saline environment. Best example is a Sindhurga fort. For the construction of Sindhurga fort, conglomerate quartzite is used as a building stone. Then next, marble. Marble, it has been formed by thermal metamorphism. Marble, it is used as an ornamental stone. The knowledge about the formation of the marble is essential because the pure marble is easily affected by the environment. That's why their engineering significance, their formation is required for civil engineering students. Next, sir, next. This is the expert who helped in framing the syllabus. First, Dr. N.J. Jadhav, Professor, Department of Earth Science, IIT Bombay. Dr. D.B. Panaskar, Professor, Earth Science, SRTM University, Nanded. Dr. S.N. Patil, Professor and Head, Department of Applied Geology, NMU, Jalgaon. Then Dr. Nikam, Professor and Director, School of Health Science, YCM, Open University, Nasik. Dr. Sheikh, Professor, Department of Geology, Parabani. Then Dr. R.B. Mule, Professor, Department of Geology, R Science College, Parabani. Next. Thank you. After this, I am here with request to our organizing committee of this workshop. Please invite two expert of the engineering geology, Professor Dr. D.B. Panaskar. If you have any difficulty, please contact me. Okay, thank you.
Aswar sir, Swami sir.
Hello.
Yes, sir.
Hello.
Sir.
Just take it forward now.
Yes, yes. Thank you, Dr. Shirke sir, for your
Okay.
presentation on the unit number 1.
Okay,
Now
sir,
I
thank you.
take the opportunity to welcome and introduce our expert of the session, Dr. Deepak Panaskar sir. He is presently, Dr. Panaskar is presently working as Professor, School of Earth Science in SRTM University, Nanded. He has got professional experience of PG teaching of 29 years and administrative experience of 19 years. Presently, he is professor at School of Earth Science, SRTM University, Nanded, as well as he is heading the Department of Geophysics in SRTM University Nanded. He is in charge of the School Interdisciplinary Studies since 2019. Professor Dr. Panaskar has received 4 government as well as non-government awards for his contribution to the society through his research and social welfare. He has been shortlisted twice for the post of Vice Chancellor and interviewed or interacted with the search committee for the position of Vice Chancellor at Solapur University, Solapur, and SRTM University, Nanded. So he has held the positions of in charge Vice Chancellor for SRTM University, Nanded, Director BCUD, Director School of Earth Science, and Head of Department of Science in SRTM University, Nanded. He has also served on various other important positions of academic and administrative importance. So he was also appointed as subject expert for the geology book by Bal Bharati Maharashtra State Pathya-Pustak Nirmiti and Research Board. He has visited 5 countries. He was actually invited to UK, Thailand, USA, Tunisia, and Egypt for global conferences and has chaired the session in prestigious scientific gatherings. He has till date guided 13 PhD students and 5 MPhil students. Also, 8 PhD fellows are working right now under his guidance, and 3 MPhil students are also working under his guidance. He has till date completed 15 research projects by the different funding agencies. The fund amount is total of 141.74 lakhs. He has published research papers, around 67 research papers, including 24 national and 24 international and 39 national in national journals. He has written 1 book chapter for a book in USA. He has published 2 books. He has presented papers in 12 conferences, seminars, and he himself has organized 28 conferences, workshops, which includes 1 international and 27 national level conferences. So he is on the editorial board or as a member and a reviewer for 12 national and international journals. So it's my pleasure and I feel honored to welcome Professor Dr. Deepak Panaskar sir for this session, and I request him to kindly share his views on this present unit or this present today's session. I welcome Dr. Panaskar sir. Panaskar sir, please.
Yeah, okay. Good morning to everybody. Thank you very much for a nice introduction. At the outset, I am thankful to BOS members and university authorities for giving me this opportunity. I congratulate Dr. Shirke for a very nice presentation. As he has also told that geology is a very, very important subject with respect to the engineering geology. And engineering geology knowledge is very, very essential for the civil engineering students. Civil engineers should know the basic knowledge of geology, because in absence of basic knowledge, the civil engineering projects may get failure. Therefore, the basic knowledge of geology is very, very essential. There are some basic parameters which needs to be understood by the civil engineers or the students. And if the proper precautions are taken for any projects, then certainly the life of the projects will be long, as well as the safety of the projects will be very good. As you know, there are different types of projects which are taken by the civil engineers, like for example, highways, construction of the highways, then dams, then tunnels, The tunnels may be for the road or maybe for the hydroelectric projects, then different buildings, then bridges. So all these projects, they need a basic knowledge of geology because the engineers should know what is the basement geology, what are the physical properties of the geology, and what are the geotechnical characters of the rocks which are on the ground, which are within the surface. The syllabus presented by Dr. Shirke is very, very excellent. The points or the bits which are covered in the syllabus are very, very essential with respect to the engineering point of view. Syllabus covers all the points or the bits which are required for the studies which are very, very essential for implementation of any project. The weightage given for each bit is also correct. The syllabus provides the basic concept of geology, engineering geology, and physical properties of minerals and the rocks. The geological knowledge will be very useful for the studies of planning and designing of different projects. There is a wide scope for the geological applications, like for example, town planning, water resources, maybe for the construction of the percolation tanks, dams, and big reservoirs. And for these, the geotechnical information are the studies which are very, very essential. And if this knowledge is given to the students, certainly they will plan any project in a better manner. The sustainability of the project is very, very important. And we know that there are many cases which have occurred, that collapse of the bridges during the construction. And this has happened maybe because of the lack of knowledge of the geology, or even though the knowledge is there, the proper precautions are not taken. And because of that, the failure of the projects has occurred. So for any project, the site selection is also very, very important. While selecting the site, what are the rock types which are available there, then what is the soil, what are the physical and chemical properties of the rocks, what are the fractures or structures, if at all there are present. So all these studies are very, very essential while selecting the site and for the implementation of the projects. Because as it is told by the Dr. Shirke, that geohazards, it is also included, because nowadays in the earthquake prone areas, if you want to construct the houses or the buildings, big buildings, then you have to take proper precautions, the foundation and other things which are required, because the sustainability of the building should be there. Even though the bigger the syllabus is designed very nicely, which covers the igneous rocks, sedimentary rocks, metamorphic rocks, minerals, their physical, chemical characters, the classification of the rocks, then the study of the engineering properties of the rocks, then rock mechanics, then the stress and strength of the rocks, which is very, very important. So for some units, there are less lectures which are given, but as per my opinion, the more lectures should be given, because the syllabus is very good, and to cover each and every point in detail, the more lectures should be assigned to this syllabus. I think this is my opinion. Thank you very much.
Thank you,
Thank
sir.
you, Dr. Panaskar, for your expert comment about the syllabus content. We appreciate your efforts and the guidance given regarding the content of this first unit. I will request now participant to please post their queries in the chat box. Chat box is now open, and your queries will be answered by both speaker and the expert if required. Please put your queries.
Dr. Aswar, I will take just a minute.
Yes, sir, please.
I would like to thank Dr. Shirke and Dr. Panaskar. As many of you know, particularly the geology people like Dr. N.J. Sate, Dr. Swami, that geology is very close to my heart because I have learned geology from Dr. S.R. Kulkarni. My B elective was geology. My project was in geology. So even I remember all my lectures of Dr. S.R.K. So I'm really thankful to you. And I was in this session for the whole time because geology is closer to my heart than like any other engineering subjects. So I will just take leave from this session and I will be joining BTAP. I will join session 2 a little later. Okay. So thank you very much, sir. Once again, thanks a lot.
Thank you, sir.
Participant, please post your
Yes.
queries.
Participants, please post your queries.
Basically, my fellow friends, remember you are teachers and it is expected that there should be some queries related to mineralogy or petrology because you are going to deliver the lecture series henceforth for the students. This was just a guideline approach towards learning the mineralogy and petrology. And if you consider this one, your own PPTs will be more enhancing for the students to understand the mineralogy and petrology. Any mineral which has its own properties. For example, if you share about the mica minerals, they have one set of cleavage or likewise. They are very weak minerals. And if these minerals are occurring in the rock, what will be the compressive strength of the rock? One should understand this fact. You have to correlate each and every aspect of geology to understand, for the better understanding of the rocks, which is going to be used as a building material, maybe at the foundation level or maybe in the construction phase. Probably, if you look towards limestone, it is the core rock for formation of cementing material. And if you understand this cohesiveness of geology with engineering aspect, with technological aspect, then and then only this geology can be a subject of loveliness, or it will be more understandable for the stakeholders of civil engineering. That is from my part.
Yes, Sate sir, very well said. If participants they have some queries, they may ask through the chat box. Yes, we have got one query from Mr. Prafulla Pise to he is saying, dear sir, good morning and thanks for your guidance. Could you please recommend any good textbook for theory and lab covering updated syllabus, please? So he's basically asking for a textbook for the theory and practical purpose. So, Shirke sir, would you please like to answer this?
Hello. For the theory and practical aspects, you may use any types of a textbook, because the textbooks are published by the local author or it is in the form of the notes. But if you have to extra knowledge about the subject, then you have to refer the reference book. For example, Engineering Geology by Bandopadhyay, then Engineering Geology by the Bangar, Engineering Geology by the Praveen Singh, etc. Engineering Geology by the Gupte. These are the reference book, those which has been gives the valuable information about the geology as well as their formation of the mineral, etc. Okay.
Yes, sir.
Yeah.
Sir, there is
Thank you,
one
sir.
more. Yeah, there is one more question from Pallavi Padalkar, madam. So she is asking for the guidance for the geological map. So I think we have, ma'am, we
Well,
have, yes, we have got one session dedicated for the practical aspects of engineering geology. And at that time, Dr. Shivlikar sir and Dr. Jain sir will be,
Dr. Jain, sir.
yes, Dr. Jain sir will be explaining this part to all the participants. So we'll
Yes.
have to wait for that.
yeah, sir, we got one more query. To what extent we need to cover mineralogy aspect, because it's quite huge and vast coverage is there. But to what extent we need to restrict ourselves for teaching this mineralogy content?
In mineralogy, it is required the basic knowledge about the mineral. Basic knowledge means the definition of the minerals, then their origin, their formations, and the physical properties of the minerals. Not going in details, that is the different types of groups of the minerals, study of silicate minerals, non-silicate minerals, not going in details, but you have to give the knowledge or required or essential knowledge about the minerals, because the mineralogy is a subject, it is a vast subject. In this subject there are mineralogical, then chemical, their formations, their different types of properties. Only we have to cover here, only we have to cover those portion or those topics, those which are required for identification of the minerals and their better understanding how the minerals and their engineering significance in the formation of the rock bodies at different areas. Okay.
Can I add one more point?
Okay. Okay, sir.
I will add one more point, because as the question is, mineral identification is very essential, because, for example, if you have two rock types, two same rocks, means sandstone is there, but there are different types of sandstone. One is a siliceous sandstone, which has a siliceous cement, that is the silica, and the another is having the calcareous cement. So when the calcareous cement is there, that means the mineral in that cement is a calcite, and it will weather very fast, whereas the siliceous cement will not weather. So for the building purpose, you cannot use the sandstone which is having a calcareous cement, because it will weather very fast. Or in the areas where you have the acid rain, there immediately the calcareous cement will go up and the damage to the building will occur. So that much knowledge should acquire by the students. That is essential for the construction of the building or the usage of the building stones. So that much knowledge is very, very essential. Thank you.
Thank you, sir, for your comment.
Yeah.
Respected Shirke sir and Panaskar sir, thanks a lot for such a wonderful and informative, in-depth session. We appreciate your gracious presence for the event. Now,
Thank you
with the
very much.
position of chair, I assume that the first session is over. After this, immediately we are starting with the second session. So we got a second session on the unit 2 of engineering geology, which is geomorphology and historical geology. So within this unit, let's witness the changing structure of Earth's surface and begins the journey of past over geological timescale. So we have with us Dr. Doke. So it's my pleasure to introduce him. We will go through his biodata. I welcome you, sir.
Thank you. Yes.
Am I audible?
Yes, yes.
Yeah, Doke sir has completed his PhD in geology and he is presently working at Praura Rural Engineering College, Loni. He has a teaching experience of more than 32 years and has taught various subjects such as engineering geology, advanced engineering geology with rock mechanics, geoinformatics, and even in environmental geoscience. He has 10 international plus 10 national journal research publications to his credit. He has also worked as a consultant in core logging at various projects. So I hand over the proceedings to our next speaker, Dr. S.D. Doke, and I invite him for start of the second session.
Okay, thank you, Swami sir. I first of all express my thanks to the organizers for giving me opportunity to hold this session and to give presentation in this session. I am giving here presentation on Unit 2, that is Geomorphology and Historical Geology. This is it audible? I am audible. Hello.
Yes, sir. Yes, sir, you are audible.
Okay. Then the subject, the Unit 2 is on geomorphology and historical geology.
Dr. Doke, can you please
Yeah.
press F5 of your PC?
PPT is not available, is not visible.
It is a small image that has been, or shall I share from my side?
Yes, sir, that will be better.
You
Sir, only
better.
presentation you have to start.
Okay. Will you share it, sir?
I will share it within 2 minutes. Dr. Doke, can you stop sharing your?
Yes.
Just a minute. Huh?
Yes.
Is it visible?
Yes, sir, it is visible.
Yes, sir. Okay, now it is visible.
Next slide, please.
Okay, now I am presenting on Unit 2, that is geomorphology and historical geology. Next, sir. Next. Next slide, please. Okay. Now, the prerequisites of Unit 2 are geography, biology of secondary school, geology, zoology of higher secondary level. The post requisite of Unit 2, this unit will be helpful for following civil engineering courses: the dams and hydraulic structures, geotechnical engineering, town planning, and advanced engineering geology with rock mechanics. Thus, particularly the town planning, the planning of town is very important aspect. Okay, next, the content of presentation. I will present the syllabus of Unit 2, course objectives and outcome of Unit 2, teaching plan, and there will be detailed discussion on syllabus, then the list of books. Next, the Unit 2, geomorphology and historical geology, it consists of mainly two chapters. First is geomorphology, which includes endogenic and exogenic processes, geological action by fluvial processes, that is river, and landforms formed by river, and all the external and internal processes, aeolian and glacial processes, coastal geomorphology. The second chapter is on historical geology, which includes general principles of stratigraphy, geological timescale with respect to Indian geological timescale, physiographic divisions of India, Archeans and Dharwar formations, Kadapa, Vindhyan, Gondwana, and Deccan Trap formations, and significance of all these formations and their structural characters in major civil engineering activities. This will be covered in this second unit. Next, please. Now, objectives of this presentation: to learn geomorphic features formed by fluvial marine processes and their role, the role of Indian stratigraphy and historical geology in civil engineering projects. Outcome of this presentation: exploring importance of mass wasting processes and various tectonic processes that hampers design of civil engineering projects and its implication on environment and sustainability. Now here, because of action of various agents which are acting internally and externally, there is a lot of modifications taking place on the land, and the various landforms are created. Therefore, this topic is very important for town planners and city planners, because without the knowledge of topography or landforms, the design for town planning cannot be made properly. Next, sir. Next slide, please. The teaching strategy, introduction of the content, relevance of the earlier units, content delivery during the lectures, highlighting important keywords, uh, important keywords and their meanings, mentioning of existing projects such as dams, tunnels, roads, and bridges, preparing PowerPoint presentations, YouTube links, assignments, quizzes, short and long question answers. Next slide, please. Thus, it is a teaching and lecture plan. Already it has been discussed. Therefore, we will go for the next slide, please. Okay. Now we'll discuss on the syllabus in detail. The agents which are acting internally and externally, they are continuously modifying the earth. Action of these agents and their effects are studied in geomorphology. The various agents which are acting internally, they are called as endogenous processes. And these agents are like earthquakes, volcanoes, folding, faulting. which bring about the tremendous effect on the landform. For example, Himalayas that have been created because of folding. The huge mountains like Himalaya have been formed by the process of folding. Such type of internal processes, they are called as endogenous processes. The exogenous processes, which are modifying earth externally, they are wind, water, and glacier. Because of these agents acting internally and externally, there is continuous modification in the landform. Ever since origin of the earth, all these agents, they have started attacking on the land surface internally and externally, and because of that there is continuous development in the landform. Various topographies have been developed, landforms has been developed because of these processes. Now in exogenous processes, I am giving here with the example of river. River, it is having action externally on the land surface, and because of the action of river, the various modifications, various landforms that are created, that will be discussed in this slide, in this session. Now the next slide please. The river, which originate as a small stream at higher elevations, it has got 3 stages throughout its life cycle. When it originates at higher elevations as a small mountain stream, that stage is called as youth stage. In youth stage, because of tremendous velocity, as river is flowing along very steep gradients, there is more downcutting of the valley. And because of downcutting, the valley which is developed is V-shaped valley. The valley is V-shaped valley, and there is headward erosion. And hence, if we observe the rivers which are in youth stage, the topography is found to be, it is V-shaped valley, and the hard rocks, they are available at shallow depth. Now such topography is very much suitable for the construction of gravity dam. Therefore, whenever the civil engineers, go for the construction of dams, on the basis of landforms, on the basis of topography of that region, they have to first select the site, and then they have to decide the type of dam. Thus, type of dam is solely, it is decided on the basis of the topography of that area, and topography is decided by the action of river. In youth stage, we get V-shaped valley and with large reservoir behind it. And since the velocity is tremendous, we do not get any river deposits in this stage of the river. Next slide, please. Whereas when river reaches at lower level, the land surface is slightly, it is a gentle. And because of gentle gradients, the downward cutting almost stops, and there is more sideward cutting. And because of sideward cutting, the valley which is developed is U-shaped valley. Thus, on the basis of the shape of the valley, on the basis of topography, we can say, or we can predict the stage of the river. But now, because of the less velocity, the deposition starts. We get some river deposits in the stage of maturity. This stage is called as stage of maturity, having U-shaped valley, and there is sideward erosion. Velocity is very much, it is a less. Next slide, please. Now, when a river reaches to at still lower level, where the gradients are very much gentle, the velocity is very extremely low. Because of this extreme low velocity, the river starts taking meandering course, because whenever there is small obstruction, because of very slow velocity, it takes turns, and thus it follows meandering course. This is the main characteristic of river in old stage. Then as velocity is very sluggish, the sediment, it starts depositing sediments. The its deposit, that is, those are called as river deposits. And stage comes when river flows on its own deposit. Thus, when we observe river in old stage, it is found that valley is very flat. There are thick river deposits on both banks of the rivers. The levees have been developed, and river flows through very small restricted channel throughout the year. Only during floods it overflows the perennial channel. Now this is the characteristic of river in stage of old stage, in the old stage. And this topography is not suitable for the construction of gravity dams. This topography is suitable for construction of earthen dam, because very thick river deposits, they are occurring, and which can be used for zone of casing. The fine clay and silty material can be used for zone of hearting. Thus, all the construction material is available here. And another thing, for construction of gravity dam, we require very hard and sound rock at shallow depth. But here, because of thick river deposits, the good quality of rock, hard rock, is occurring at great depth. Therefore, it is always preferable to go for earthen dam when such type of topography is observed. In this way, we can teach students, and then it will be very, means the students can understand the importance of this geomorphology in the construction of dams. Next slide, please. Now here, the various landforms that are created due to erosion by river. Because of erosive action of river, the various landforms are created. Few examples are given here. The waterfalls, these are the common landforms created due to the action of river. When hard rock is overlying the soft rock, then as river flows along the deep direction of the layers, when these soft rock get exposed, and then the undermining of the soft rock take place more quickly rather than the overlying hard rock. And because of undermining of the soft rock, the overlying hard rock become unsupported, and it may fall down along the joint block, and over which this the water will leap, and thus we call it as a waterfall. And in this way, in the nature, there are the such type of waterfalls, they have been created. And not only formation of waterfall, but there is continuous recession of waterfall is going on. There is one important feature which has been created by the erosion. Then another, the feature which has been created by erosion, it is the oxbow lake. Now, such type of oxbow lakes are developed in the river when river is in old stage. As I already told that when river is in old stage, it follows meandering course, and there is continuous erosion at outer side of the loop, and there is deposition at inner side. Because of continuous erosion, both ends of loop approach each other, and very small neck of land is left in between these two ends of the loop. This narrow neck of land can be short circuited by the increased momentum of water during severe floods. And because of the short circuit of the course, the oxbow lakes, which are crescent shaped, they are developed. Such type of oxbow lakes, they are found in the rivers which are in old stage, which are following such type of meandering courses. Next slide, please. Then these are the features which have been created by the deposition by river. As when the river is in maturity and old stage, it starts deposition. And finally, a stage comes when it flows on its own deposits. Therefore, in the old stage, as valley is very flat and river is flowing on perennial channel, only during floods it overflows perennial channel and it covers the entire flat valley. Now that valley, which is covered only during floods, is called as flood plain. Thus, during every flood, some sediments are deposited on the flood plain, and thus flood plains are continuously rising. Such streams are called as aggrading streams. Thus, old streams, the rivers which are in old stage, they are aggrading streams. Thus, they are having floodplains. And the raised banks of river, they are called as levees. Such levees provide natural protection from the floods because the water remain concised in between this perennial channel. Okay. Thus, many times in the some regions, over these natural levees, artificial levees are constructed. Hmm. Thus, these are the floodplains and levees which are developed due to the deposition by river. The another important feature of deposition is the delta. When river enters the sea, its velocity suddenly decreases and it deposits the load at the mouth of the river. When there are no strong currents or waves to sweep away these deposits, then these deposits go on accumulating and it develop a form which roughly resembles the triangle or the Greek letter delta, and therefore it is called as delta. The deltas of the rivers like Ganga, Nile, Mississippi, they are well known. Hmm. Thus, such type of deltas are found at the mouth of the great rivers. Next slide, please. Then one more important feature, that is river rejuvenation. Thus, it indicates how the endogenous processes like folding, faulting, upliftment, they bring about modifications on the land surface. Suppose river is in old stage and that land surface has been uplifted. Okay. Then what happens? As I have told you, the river which has attained old stage, it lost power of down cutting. It starts depositing the sediments. Hmm. This river, which has lost down cutting, power of down cutting, when that land surface is uplifted, then, then what happens? The river again acquires power of down cutting because of upliftment. When it is brought high above the mean sea level, again it acquires power of down cutting. Now, such type of transformation in the river due to the sudden upliftment is called as rejuvenation. Okay. Such transformation take place means what happens? The river which was originally in old stage, now it is behaving like a river in youth stage because down cutting is the characteristic of youth stage. It is not characteristic of old stage, but river was in old stage. It has lost power of down cutting. But because of upliftment, again it has acquired power of down cutting, and such renewed down cutting is called as rejuvenation. Okay, this is called as rejuvenation. Hmm. Now, such type of rejuvenated rivers, the best example is the Colorado, the Grand Canyon of Colorado. This river has been uplifted, and after upliftment, it has down cut its valley up to 1300 meters. Hmm. Thus we can see the effect of this type of endogenic processes and effect of external processes, that is by due to the weathering action, due to the action of down cutting, it has undercut its valley up to 1300 meters. Now in this way the rejuvenation of the river take place, And because of rejuvenation, various landforms are created. The next slide, please. Now, these are the landforms created by rejuvenation. Thus, we can explain to the students that how various landforms they are created by the rejuvenation of river, landforms created by river erosion, landforms created by river deposition. Hmm. Thus, due to the rejuvenation, such type of very deep gorges and incised meanders. Hmm. The river, which is in old stage, it follows a meandering course. And when this river get uplifted, then it acquires power of downcutting, but its meandering course is retained. And therefore, they are called as incised meanders. Such type of incised meanders and deep gorges are the example of landforms created by rejuvenation. And thus these are the river terraces. The because of the deposition by river, the flat terraces are developed. And because of down cutting, river goes to the deeper and deeper level, having to the flat terraces on both banks of the river. Such features are created due to the rejuvenation. Next slide, please. Okay, now we are switching over towards the next chapter, that is stratigraphy. Now, as we have discussed, the various changes have been taking place ever since origin of Earth, and since the water, wind, and the glaciers came into existence, they started modifying the Earth. Various changes
Dr.
have been
Doke,
taking place ever since origin of the. Yes, sir.
your
Yes,
voice
sir.
is not proper audible. Can you hold your mic near to your face?
Hello. Hello. Now is it okay?
Yeah, yeah.
Yes. Okay. Now, various changes have been taking place ever since origin of the Earth. Continents have drifted. Continents and oceans interchange their places. Mountains have uplifted and washed down to the base level. The various forms of life flourished on the Earth's surface and disappeared. Climates have been changed from glacial to tropical and tropical to glacial. All these events, which have been taking place since the origin of Earth, are to be arranged in proper sequence to compile history of the Earth. To, for the formation of history of Earth, all these events are to be arranged in proper sequence. By operation of sedimentary cycle, the sediments have been deposited all over the world. And in these sedimentary rocks, history has been recorded. The fossils which were in existence during that particular time, they have been preserved in these sedimentary rocks. And with the help of these fossils, as there is the common trend of evolution from oldest organisms to highly evolved youngest organisms. On the basis of these fossils and their trend of evolution, all these sedimentary rocks scattered all over the world, they have been arranged on the basis of relative ages. Thus, with the help of fossils, we can determine relative ages. And with the help of radioactive elements, we can determine absolute ages. Thus, by using these fossils and by using radioactive elements, all this standard stratigraphic scale has been determined. The standard stratigraphic scale has been formulated on the basis of the fossils and radioactive elements. The next slide, please. Satya sir, now my voice is clear now? Okay. Now, as thus, with the help of fossils and radioactive elements, the standard stratigraphic scale has been prepared. Mhm. And it has been divided into era and periods. The oldest era is called as Precambrian era. Then it is followed by Paleozoic era, Mesozoic era, Cenozoic, and Quaternary era. Thus, these are the various eras. The oldest era is called Precambrian era, or it is also called as Azoic era. Because why it is called as Azoic era? Because after the formation of Earth, let us now the regarding origin of Earth, it is said that the Earth has been originated some 4,500 million years back. Age of Earth is 4,500 million years. And age and the first fossil that has been observed, that is only having age of 600 million years. Thus, this time gap in the formation origin of Earth and the evidence of first life on the Earth is 3,900 million years. Okay. Thus, after origin of Earth, for 3,900 million years, there was no life. Therefore, this era is also called as Precambrian era. This era is called as Precambrian era, or Azoic era, or Precambrian era. Now, when we correlate the formations of Indian stratigraphy with standard stratigraphic scale, then we get Archean system, Dharwar system. These are the oldest formations. Archean and Dharwar are the oldest formations as far as Indian geology or Indian formations are concerned. These formations are called as basement complex because they are occurring at the base and they are showing very complex structures. Now we are going to introduce, or we are going to teach students the details of all these rock formations of Archean system and the rock formations of Dharwar systems. The Archeans, they are made up of granites. Mainly we get granites in Archean system, which are the plutonic igneous rocks. Then we also get gneisses. Gneisses are also found in Archean system, which are metamorphic rocks. And these metamorphic rocks are created due to the dynamothermal metamorphism of granites. Thus, in Archean system, we get the granites and gneisses. Then the Archean system, it is followed by Dharwar system. The Dharwar system, this name has been given from the Dharwar district of Karnataka, as these formations were first studied in Dharwar district. Now, these Dharwar formations, they mainly consist of metamorphic rock schist. There is a difference in schistose rock and gneiss rocks. The gneiss is mainly having large proportion of rounded minerals, whereas schists, they are having elongated minerals. Therefore, there are weak planes in schist. In metamorphic rock schist, the weak planes have been developed. Therefore, they are very important from the point of view of the foundation rocks. The niches are advisable at the foundation of dams, but when they are schists, then because of weak plains, there can be the settlements. If the resultant of
Hello. Hello.
Okay, sir. Hello.
Okay, sir. Is he there?
Hello.
Lokesh, better check whether he's in.
Aswar sir?
No, sir, he has not yet joined.
Salte sir? Hello?
हाँ बोला.
सर डोके सर ना हे co-host केले मी आता.
केलंय ना?
हो केला जस्ट केले.
हो ते आलेत माझ्या मते.
बाबर सर.
हा बोला
लोकेश
सर.
सर.
हा तुमचं तो बहुतेक व्हिडिओ हे होतोय.
लोकेश सर.
हा सर.
डोके सरांच्या अच्छा ओके दिसतंय आता. ते
हो.
माईकचा सिम्बॉल दिसत नव्हता.
त्यांच्या इथून कनेक्ट
मायक्रोफोन.
झाला.
हा
आला.
आलेत.
आले सर.
येस.
Yes, sir. Now, thus, as सुरू करू ना?
Yes, sir. Please.
Okay.
Resume your
Now,
presentation.
as we are discussing about the various formations of Indian stratigraphy, the Archeans are the oldest formations, which are made up of granites and gneisses. Dharwars are made up of schists. Now, these metamorphic rock schists. Now, after formation of Dharwar system, all these Dharwar formations were subjected to great compressive forces, and because of which the lofty mountain chains were formed. The Araulis of today, they are mere roots of all these ancient fold mountains. Therefore, we always say Araulis are the oldest mountains. Thus, after the folding, the mountains have been formed and they have been eroded to the present level. Now, this period, this vast span during which all these older formations were subjected to weathering and erosion, that period is called as Eparchian unconformity. That is called as Eparchian unconformity. And because of such a great erosion and weathering of the older formations, the sediments have been created, and these sediments deposited over the older formations, and the Kadapa and Vindhyan systems came into existence. Thus, Kadappas and Vindhyans, they are made up of sedimentary rocks. After Eparchian unconformity, there is a Kadapa formation. And the Kadapa and Vindhyans, they are made up of sedimentary rocks. Almost all sedimentary rocks, limestone, shales, sandstones, conglomerates, we get in the Kadapa and Vindhyan formations. Now, as far as economic importance of all these systems are concerned, the basement complex rocks, they are economically very important. Almost all metals, metallic minerals, non-metallic minerals, we get in the Archean and mostly in the Dharwar systems. Therefore, Archean and Dharwar formations, which are called as basement complex rocks, they are economically very important. Then Kadapa and Vindhyan formations, they consist of building stones. They are well known for the building stones. Most of the historical and monumental buildings that have been constructed in ancient times in our India, they have been constructed by using
the sandstones, which we get in very large quantity in the Vindhyan mountains. Those, these Vindhyan system provide excellent quality of building stone. That is a sandstone. Thus, limestone is also extensively used in the cement. The all type of sedimentary rocks we get in these Kadapa and Vindhyan formations. Then another importance of Vindhyan system, it also consists of diamond. Diamond is found in the Vindhyan system. Thus, these are the two systems which consist of the sedimentary rocks. Now, thus all these four systems, Archean, Dharwar, Kadapa, Vindhyan, and Gondwana, their span is of only Precambrian or Azoic era. Then for a long period, there was no evidence of any the deposits. Towards the end of Carboniferous period, up to Jurassic. From Carboniferous to Jurassic, it is the span of Gondwana system. The Vindhyan system is followed by Gondwana system. These Gondwana formations are also made up of sedimentary rocks. And another importance of Gondwana system is the coal deposits. 80% of coal which is recovered in India that comes from this Gondwana system. How this Gondwana system came into existence? In the beginning of Carboniferous period, the climatic condition was very much favorable for the growth of plants. And during this period, luxurious growth of plants took place. Then afterwards, land surface was subjected to tensional forces, along which the faulting took place, large troughs were developed, and in these troughs, all the plants were buried. And from these, the coal formation took place. Therefore, this age, it is called as Carboniferous period. Now, this, the span of Gondwana is Carboniferous to Jurassic. Okay. And thus we get almost all coal deposits in the Gondwana system. Now, another important aspect of Gondwana formation is that all the climatic changes that took place, they have been preserved in Gondwana formations. The fossils have been preserved in the Gondwana formations, and because of these such type of climatic changes and because of the fossils, it has helped a lot in formulating the continental drifting theory. The Gondwana formations which are occurring in India, the same type of Gondwana formations having same fossils, same trend of evolution, same sedimentary deposits, they are observed in other southern continents like South America, Africa, Antarctica, Australia. And thus, with the help of this, we can say, once upon a time, long back in geological past, there was a single landmass called as Pangaea, which got drifted into southern subcontinent, that is Gondwana land, and Laurasia. And then Gondwana disintegrated into all southern continents. This theory can be well explained because of the Gondwana formations. Then after Gondwana, there is a youngest formation, that is a Deccan Trap. And we give more stress on the study of Deccan Traps since the 85% of Maharashtra, it covers the Deccan Trap. It covers 5 lakh square kilometer area of India. The main plateau, that is a Deccan Plateau, which is occurring in Maharashtra, which is covering 85%. Then it is also found in Madhya Pradesh, Gujarat, part of Karnataka, and Andhra Pradesh. Thus, this 5 lakh square kilometer area has been covered by Deccan Trap. How this Deccan Trap came into existence? Because of eruption of mobile lava in very large quantity. Towards the end of Cretaceous period, due to great tensional forces, cracks were developed, and through these fissures, very vast quantity of mobile lava erupted, and it has it has buried all the older formations. Therefore, in the core of Deccan Trap, we never get the older formations. Now, we have classified all these older formations and Deccan Trap and older formations and Deccan Trap. And in our the in teaching during teaching we explain all these formations as formations older than Deccan Trap and Deccan Trap formations. We also give the case studies of the dams which have been located on the Deccan Traps and case studies of the dams located on the older formations like Kaladgis, then Archeans, Dharwad formations. What problems have occurred when the older formations are occurring at the dam foundation. Thus, we can correlate all this stratigraphy with the all other the forthcoming chapters of engineering geology. Thus, it has got great importance in the study engineering aspects of various rock formations, which are whether they are older than Deccan Trap, and also we teach the engineering aspects of Deccan Trap basalts. We used to teach the different types of basalts like compact basalts, amygdaloidal basalts, their field characteristics, how the field characteristics of basalts are useful in deciding the engineering project. What are the water bearing characteristics of the basalts? Then in addition to these basalts, we also teach the associated features like tagmatic basalts, volcanic breccias, then dikes, river alluvium. All these aspects are covered in this chapter. So, okay, next slide, please. Now, this is about the Indian geology. Geologically, our India can be classified into two types: the peninsular India and extra peninsular India. The southern triangular portion, which is covered from all three sides by the seawater, Arabian Sea, Bay of Bengal, and Indian Ocean. That triangular portion is called as peninsular India. And whereas northern portion, north, northeast, and northwest, bordered by Himalaya, it is called as extra peninsular India. And the central portion, which is occupied by the deposits, river deposits of Ganges River, that is Indo-Gangetic. Now, in this case, though the peninsular India and extra peninsular India, these are the parts of same country, India, they are totally different as far as geological structure is concerned, geological history is concerned, and geomorphology, that is the physical aspects are concerned. Now, when we talk about geological structure, then it has been observed that peninsular India is made up of almost horizontal strata. All the rock formations of peninsular India, they are almost horizontal. They are, or at few places, they are just gently dipping. Hence, in civil engineering works, we don't have to face much problems in as far as peninsular India is concerned. It is considered as a stable land mass, which is called as shelf. On the other hand, when we see the structure of extra peninsular India, which is quite different, totally different from the peninsular India, because it has been subjected to great compressive forces by which the fold mountain Himalaya has been formed. Therefore, rock formations of extra peninsular India are highly folded, faulted. They are intruded by various igneous intrusions. They are almost crumpled, and they are always subjected to the great deal of earthquakes. Hence, this is a very problematic region for the civil engineering activities, and that is because of the folding that has taken place. This is about the structure. Then, when we consider the history, then the interesting thing is that the peninsular India, it remained as a land mass since Cambrian times. Since Cambrian times, it never submerged under sea. It remained as a land mass. On the other hand, the extra peninsular India
it was under sea from Cambrian till Tertiary period. Okay, it was under sea for a longer period. Only recently, that is around, we can say some 65 or 70 million years back, it has been uplifted. And therefore, Himalayas are youngest mountains. And they were under sea for very longer period, Cambrian to Tertiary. And during Tertiary only, it has been uplifted. Thus, it is the, as far as history is concerned, there is a quite difference in the peninsular India and extrapeninsular. And third aspect is geomorphology. That is a physical aspect. That is, as far as the rivers are concerned, these rivers of the peninsular India are in old stage, and rivers in extrapeninsular India are in still, they are in youth stage. They are continuously down cutting valley. And mountains, as we have just seen, the mountains of extrapeninsular India, they are fold mountains, and mountains of peninsular India are relict mountains. They are not true mountains, but they have been formed due to the circumdenudation. Thus, the peninsular and extrapeninsular India, they are quite different from each other. Next slide, please. Thus, it is just a review of various rock formations which are occurring in different systems. The basement complex rocks, that is Archeans and Dharwars. Then the lithology of this Archean system, granites and gneisses, lithology of Dharwar system, schistose rocks. The economic importance, as I have told you, all the metallic and non-metallic minerals we get in the basement complex rocks. Then they are followed by Kadapa, a Vindhyan system. Their economic importance already we have seen. The Gondwana system, its economic importance we have seen. The next slide, please. Now the main aspect is the Deccan Trap. The 5 lakh square kilometer area has been covered by this Deccan Trap basalt. Its thickness is variable, but maximum thickness of 3000 meters is found near Bombay coast. As far as lithology is concerned, the main rock type is basalt, which is having composition, plagioclase and augite. And on the basis of mineral composition, we can classify the different types of basalts. The plagioclase augite basalt, olivine basalt, Eadingite basalt. These are the some few examples of basalts which have been classified on the basis of mineral composition. Then on the basis of textures, we can name them as a compact aphanitic basalt, compact porphyritic basalt, giant phenocryst basalt. I will not explain it in detail. These are the various types of basalts which have been classified on the basis of their texture. Now, but on the basis of field characteristics, on the basis of field observations, from civil engineering point of view, we recognize only 2 types of basalts. Those are called as CB, which is abbreviation of compact basalt, and AB, which is abbreviation of amygdaloidal basalt. Those basalts which are free from vesicles, but which are having joints, contraction cracks, they are compact basalts. And those basalts which are having gas cavities, and the gas cavities are filled up by secondary minerals, they are called as amygdaloidal basalts. The field characteristics of compact basalts are different from the amygdaloidal basalts. And these field characters are very important from the civil engineering point of view. The compact basalts, if we observe our Sahyadri ranges from distant places, we can see the horizontal flows of basalts. We can see horizontal flows of basalts. Thus, compact basalts are occurring in the form of thick horizontal flows. Whereas amygdaloidal basalts are formed they are occurring in the form of undulated flows. They are occurring in the form of undulated flows. So it is a difference in their field characteristics. Though compact basalts are jointed throughout the major portion, but small portion towards the top, it is vesicular amygdaloidal. small portion of at the top of thick extensive flows of compact basalt. It is unjointed. It is just like a amygdaloidal basalt. It is almost amygdaloidal in nature. Therefore, if we observe the many tunnels that have been excavated in our Borghat and Thalghat sections for roads and railways, they have been excavated through the top portion of thick flows of compact basalt because those portions are unjointed. It is amygdaloidal. Therefore, amygdaloidal basalt is suitable for excavation of tunnels. Thus, we can explain how the field characteristics are important for deciding the tunneling or any civil engineering projects. Hence, the field characteristics of different types of rocks are very important, and that are taught in this chapter. Okay. Now, the various textbooks and reference books that have been that given in the slides. Mainly, as far as civil engineers are concerned, I recommend that the book of R.B. Gupte, the textbook of geology by R.B. Gupte, it is a very excellent book, and every civil engineer should have this book. Now, these are online resources. Experts who help in framing the syllabus. The list of experts is given here. Now, thank you very much for giving me opportunity and for your patient hearing. Now, I request the expert for this session, Dr. Babar sir, to express his views. Thank you very much.
Thank you, Doke sir. Dr. Doke sir, thank you very much
Yes,
for
sir.
your wonderful presentation on unit number 2. I would like to welcome subject expert Dr. Babar Sheikh sir to our this session. I take this opportunity to welcome and introduce him on behalf of organizers. Dr. Babar is has the total is right now he is working as associate professor in the Department of Geology, and he is associated with the Department of Geology in Jnanopasak Shikshan Mandal College of Art, Commerce and Science, Parbhani. He has got total experience of 22 years in teaching. His specialization is in quaternary geology and geomorphology. So he is recognized research guide for by the University of Nanded, that is Swami Ramanand Tirth Marathwada University Nanded, and he is also a recognized guide by Dr. Babasaheb Ambedkar Marathwada University Aurangabad. So he has a number of 4 students working under his guidance for the PhD work. He has published 23 papers in journals, 13 in books, and 30 papers in various proceedings. He has conducted 2 conferences and attended 34 conferences. He is the fellow or he is member of 7 different professional bodies. Few to name: Geological Society of India, Indian Geological Congress, Indian Institute of Geomorphologists, and Association of Geologists and Hydrogeologists, Gondwana Geological Society, and Mining and Metallurgical Society of India. So he has received 5 awards, including Best Teacher Award from SRTM University Nanded. So it's honor and pleasure to welcome Dr. Babar sir. I request you to please share your views on this session.
Thank you. I think I must be audible now.
Yes, sir, you are audible.
Yes,
Okay.
sir.
Thank you for giving the introduction of mine. I'm really glad to join with you, all the engineers. And it's very, I think I'm honored that the topic of my interest, actually, I am very much interested in doing the researches on geology, actually geomorphology and quaternary geology. And one of the topic here is the geomorphology. Another very important aspect that I am teaching since my teaching days of 32 years, actually. The information gathered may be very old, but I have completed my 32 years of teaching, and I'm teaching this 32 years the stratigraphy of India, that is Indian geology of India. So it's my pleasure to join with you, friends. While presenting, Dr. Joke has already mentioned all the aspects which are very essential regarding the understanding of geomorphology and even the stratigraphy of India. Stratigraphy of India, he has mentioned all the aspects that are pertaining or related with this aspect. Now, few things I would like to mention here from geomorphology point of view, that the syllabus is very simple and it's very easy to understand by the students. They can get very much benefit from this as very scoring for them because geomorphology here is the river, wind, glacier, and the, we can say, coastal geomorphology. These are the four important aspects of geomorphology. Exogenic and endogenic work. Endogenic has not been included in this aspect. It may be a separate paper. Exogenic geomorphology is here. And in this exogenic, the forces of exogenic activity, running water, the wind, the glacier, and in case of the another aspect of water, the oceanic or coastal waves and their impact on the coastal areas. So from the point of view of geomorphology of the river, it starts with its origin and it meets further final to the sea in the form of the, we can say, delta. During this travel, the different stages of the river are there. And these are different to three stages of river: youthful stage, immature stage, and old stage. In the youth stage, the value deepening is more, kinetic energy is more. And as the kinetic energy is more, these are the areas where they can be excavated by the rivers, and a lot of different work have been carried out by the river. And this way, the river have the particular, I think, influence on the part of this part of the earth, where these areas are very much important from the point of view of the civil engineers, because in these areas of the actually youthful stage, generally large dams are being constructed, and for the construction of dams, so what type of geological situations are there, which valleys are favorable for constructing the dams and other things are very important aspects which are there in the riverine field. Further, when it moves downstream, its valley widening is more, and after the valley widening is more, deepening is simultaneously also there, but widening is more, and the meandering curves and other curves are there, which is in the mature stage. And here also some places we have to construct the dam, and these are the sites suitable. Then engineering point of view, that means the foundation structures and how to be, the structures are to be located in these particular areas. Where by studying the geomorphology, rather we can say geology of that area, structural aspects of that area are to be taken into consideration during this aspect. But this geomorphology plays another important role during the mature stage also. But old stage, I don't think many more, apart from the barrages, the dams are there or not. Okay, but the other areas, which are the glacial areas, glaciated areas, civil engineers have certain different type of work there, not the construction of dams and other things. Even some aspects of the desert conditions are very essential to know, to understand these geomorphologies, because these actually we can say civil engineers, they should also have understanding of what is the geomorphological repercussion of that particular area of desert, how in such areas we can construct the different types of the structures in that particular area. So for that understanding of the geomorphological situation associated in any part of India, we can say like the part of the Himalayan terrain, or like the part of the desert condition of Rajasthan, or in the parts of the Indo-Gangetic alluvial plain, or the riverine conditions of Maharashtra, where the plateau situations are there. In plateau, how these rivers are there and how these rivers are making a particular influence on the aspect of that particular area, and then how these constructions and the works can be constructed. In Marathi, there is always said that पाणी अडवा आणि पाणी जिरवा. अडवणं आपल्या हातात आहे, पण जिरवणं आपल्या हातात नाही, असं ते म्हटलं जातं. Like that, the situations are there. This means that whether that particular area which has been selected for construction of dam or construction of the percolation tank or whatever the structure it might be, we have to understand the geological situation of that particular area, considering the geomorphology also, whether the lineaments are there, whether the fault pavements are there, or whether the jointing patterns are there, fracture lineaments are there. All this we have to take into consideration along with the geomorphological, we can say, aspects, and then these particular areas can be developed. After this, the coastal geomorphology, even India is a very big resource of having the marine situations in the three sides of peninsular India, as the professor has already explained what is the peninsular India. And in these particular aspects also, we have to have certain works, certain construction works, certain civil engineering works to be carried out in these particular areas also. So therefore, the engineers must have understanding of what are the waves, what are the breaker waves, what are the carrier waves, and what type of waves have particular impact on the coastal situation, and then also the different jointing patterns in these particular areas and so on. All these aspects are very essential to understand the civil engineer regarding the geomorphology. Now, regarding the stratigraphy of India or the Indian geology, as already has been explained by Dr. Sir, that all the aspects regarding stratigraphy, stratigraphic principles, then the stratigraphy of India with reference to the Archeans, Dharwarian, then Vindhyan, Kadapa, Gondwana, even Deccan Plateau. Basics of all these things must be understood by the engineers, because if these things are known to them, if these things are familiar to them, they can understand what type of rock is there in that particular area and what geological conditions will be there for that area. Even they can understand what the jointing pattern may be there. Is there any fault? Is there any fold? Is there any unconformity associated with that particular area? All these things they can understand. While talking on stratigraphy of India, we have to understand the stratigraphic principle with reference to starting with the correlation, principles of correlation, principles of stratigraphy, including the principles of stratigraphic, we can say, correlation, then uniformity Arianism, principle of faunal succession, and principle of order of superposition. These things must be understood by the student so that they can have perfect understanding of the stratigraphy. So after that, they must have understood the physiographic divisions of India. Sir has rightly given all the aspects of the physiographic division. Yes, okay. Now, another very important thing, as they do not have paleontology to be studied, but they must have understanding of the basics of the time scale, stratigraphic time scale, that is, we can say, standard geological time scale is very essential for known to the students of any geological study. That means if they are even engineer and they are studying the geological aspects of this for the civil engineering aspect, then they must have also the understanding of at least a few parts of the time scale, standard geological time scale, broadly divided into what these eras are there, eons can be there, then periods of a particular era, at least the basics of the time scale must be understood, so and so that they can have understanding. Now, if we start with the Archean Azoic era, then we have Dharwarian rocks found in that particular area, dominant Indian, we can say Dharwar. So Dharwarian plateau. Then, as sir has already explained, what are the economic importance and what are the parts of this particular. Then after that, Precambrians are there. Precambrians, we have two types of Precambrian. That is the Proterozoic era, earlier Precambrian and later Precambrian. Earlier Precambrian, we have Kadappas. Later Precambrians, we have Vindhyans. So Vindhyan, Kadappa, their economic importance and their rock types. So all these aspects are there. Another very important, after that, we have the Gondwanas are there, right? From the Carboniferous up to Triassic, Jurassic, Cretaceous, Gondwanas are there. Gondwanas stop, the emergence of Deccan traps is there. So Deccan traps started in the Upper Cretaceous period and they continued up to Lower Eocene. That period is there. So that basics of the time scale must be understood, and then the student must have the understanding of the stratigraphic situation of that particular area. Now, while speaking the stratigraphy, you must have given some very simple points to start with the chapter. Suppose I am starting the Dharwar or Kadappa or Vindhyan. If I am starting any supergroup, so I must divide these chapters or these, we can say, formations or supergroups into very few smaller, we can say, headings. So first heading, we have to give age. So age of the Deccan Trap, age of the Kadappa, age of the Dharwar, age. Age is followed by type area, which is the area most dominantly found having the important, we can say, aspects of these, either Kadappa or Vindhyan or whatever the supergroup is there. So type area. So age, first point. Second point should be type area. Third point, introduction. What is the meaning of that Kadappa? What is the meaning of that Vindhyan? Where from that word has come into existence? Or who has designed or who has coined this name? And this type of introduction, and what are the basics of that introduction? So age, type area, introduction. Then another heading must be rock types. What are the important rock types that are found in this particular area, in this particular supergroup formation, whatever it may be? You have to give the rock types. After the rock types, we can just mention the name is having any part of the structure is there or not. So if we ask about, if we discuss about Dharwar supergroup, it is vast, consisting of a large number of folds, faults, structures, joints, and components, and so on. Like this, whether the structures are available in that particular. So after the rock type structure, after the structure, fossils. Is there any fossil? Dharwar, we don't have fossil. Kadappa, starting of the fossils is there. Vindhyans, fossils are there. So like this, is there any fossil? This short heading must have been given. Then we have to speak about distribution. Whether these rocks are found in other parts of India or not, their distribution in one paragraph, that is sufficient. After that distribution, then we have to give general idea about the stratigraphic succession of that particular area. So stratigraphic succession, suppose for example, we are speaking about Kadappa. Kadappa is divided into Papagni, Chair, Nallamalai, Krishna. 4 groups are there. Further, they have been divided into subgroups. Like this group, subgroup, if possible, if it is feasible to give these students that idea of this, we can give that idea also. And then the last part is the economic importance. Dharwar, we can say lot of 20 number of books are there for Dharwar, and we can say economic importance. Like this, we can have the description of all these aspects which have been there. I think very important aspects are there. These aspects must be known by every student of geology, whether he is a civil engineer or any other. He must have understanding of all these aspects, very essential aspects of geology. It should not be ignored by having dryness or having some difficulty and other thing, but it must be taught. So I think this must be sufficient from my side. I don't know whether what expectations are there. If some questions are there, we can discuss about this. So over to Doke sir. What can be there?
I think there are some questions.
Yeah, we can discuss.
Mahesh sir, questions सरांना द्या.
Yes, sir. Yes, sir. So there is a question from Bhakti Vaidya ma'am that the session was content rich. Please explain what is meant by aggradation.
Aggradation and degradation, these are the two processes are there. In process of aggradation, the continuous, so we can say, gathering or collecting or the depositing the sediments or a particular material which has been excavated or which has been, we can say, eroded out from that particular region, aggradation processes are there. And then sometimes when the energy is more, kinetic energy is more, it may be degraded, it may be carried out or carried away from that particular area.
Yes, sir. I think that would have now the next question is how in by Sanjay Sawant, how endogenous and exogenous processes will affect on civil engineering structure.
Yes, there are two.
So you are not audible.
I think yes, Babar sir.
Now
Yes.
I unmute, sir.
Yes, sir. Yes, sir.
So there are two forces, generally speaking, they are there on the Earth's surface where these modifications are going on. Endogenic forces are there. Endogenic forces are created within the Earth's interior. These forces are created because of the convection current generated in the Earth's mantle, Earth's, we can say, magmatic phase, which is in the asthenosphere layer. The convection currents are generated there. These convection currents are responsible for migration or movement of the plates of the Earth's surface. And because of this movement of the plates, because of this, we can say the continuous movement of these convection currents are responsible for the convergent movement or divergent movement. In case of convergent movement, the two plates collide towards each other, and divergent movement, the plates move apart from each other. Divergent movements can create the formation of the subduction zones as well as, rather we can say, trenches there, or the mid-oceanic ridges actually. But convergent movement, when they takes place during this endogenic processes, the convergent movement, they are responsible for generation of the mountain building activity. They are the diastrophic movement, and this diastrophic movement, they can cause the formation of a mountain. The mountain system may be block mountain, maybe the different types of a folded mountain chain. As we know, the examples of Himalayas are there. As we know, the examples of the Alps and Andes mountain systems are there. Another example of a block mountain system, Vindhya mountain systems are there. Rift Valley system, the Rift Valley, Khatsdari Jalamune, if Rift Valley system of the Narmada is there, whatever it may be, these are the endogenic forces which are responsible for development of a mountains. Horse type of mountain or graben type of mountains may be there, and maybe the we can say folded mountain systems are there. All these endogenic forces are responsible for generation of the mountain building activity. And these mountains, if they are there, they do sometimes in some places may have active seismic activity. These areas may have certain times, sometimes in some places, active seismic activity. And in these areas, if we have to construct the civil engineering project, whatever it may be, maybe the dam or maybe the channel and other thing, you have to be very careful regarding the aspects of whether the fault structures are there, folded structures are there, which type of folded structure is feasible, in which direction, if we take the alignment of the tunnel will be suitable, or which dam site may be suitable. These type of the things have to be taken into consideration during the activities or during the, we can say, study at the endogenic activity of a particular area. Regarding the exogenic, bahya, outer, on the surface of the earth, in this exogenic activities, we have the different we can say agents of geomorphology. Agents of geomorphology which are such as the agent of, we can say, river, that is a running water agent, maybe in the form of stream, maybe in the form of the smaller we can say rivolute, or it may be a river or a big river system. So that is a running water aspect. Then it may be lacustrine, lakes are there. It may be glaciers are there. It may be the exogenic activity done by wind in the desert area, which is a prominent area. Desert areas may be there. And the activity done by the coastal waves in the areas of the coast. So these are all exogenic activities. In these exogenic activities, even though we do not have as like that of the endogenic activities, some we can say fault, and the active structure, it may be active structure there also in the exogenic areas where the river system might have been affected by the fault also. It might have been affected by the lineament, which are joints or fracture in that particular area. So it depends upon what type of the area is there, what activities are there, and in these areas, maybe civil engineering structures, when we have to locate, we have to take into consideration again all these aspects there. So these are, I think, so the exogenic and endogenic activities which are associated with the geomorphology. Thank you. Another question, sir?
Yes, thank you very much, sir, for your elaborated answer. Maybe the query was satisfied. Sir, there is one more question from
Yes.
Pranit Nage, sir, who's asking for, could you please explain the old stage of river and levees or terraces in brief again?
Yes.
So is it, okay, please, sir.
Old stage of the river. Actually, from mature stage, when in the mature stage, we can see that the river is widening takes place. And during this river widening, the width of the river has been increased. And then in this width of the river, sometimes the channel during summer is concentrated in a very narrow channel, and the wide floodplain is there in that particular, we can say, river in the mature to old stages. So in the middle part where the river is there, or sometimes it may have 2-3 more channels also within the channel, braided type of channels can be there. And when the channel which is within the middle part is the present, we can say, present day channel of that particular river, and the whole remaining is the floodplain. So when a flood comes, the whole river can be flooded, the whole river channel can be filled with, and then the banks or the both side, the right bank and left bank of that particular river, both these, they do have the formation of a natural levee. These natural levee might have been flooded, might have been caused because of the flood has carried the sediment to that particular area. So within the channel, the natural levees can develop, temporary natural levees can also develop, but sometimes at the end or at the border part of this channel, we can have the natural levees have been developed. This is in the mature stage. Further it moves and towards the downstream. In the downstream areas also very wide, we can say, channels are developed. And as we know that within the channel, if number of channels develop in the mature stage or even old stage, we can call them as braided channels. But when it moves towards the deltaic region, in the deltas, the number of channels still we can see there. These channels are not called as the channels, but they are called as distributaries of the delta. So deltaic region, they have distributaries. So these distributaries are formed in that particular area. So I think might be this sufficient for him.
Yes, sir. Yes, sir. Yes, sir. Yes. Maybe Dr. Doke sir may answer this. That in geomorphology, aeolian and glacier, their erosional and depositional features and their formation are enough, or we need to add more. So maybe
no, it is
Komal Shinde ma'am is asking this question.
Yes. Shall I answer or Dr. Sir is answering?
Sir, maybe this is related to the extent of the subject. So, as per the requirement of the syllabus, so maybe Dr. Doke sir may answer this.
No, aeolian deposits and glacial deposits. Aeolian deposits means the sand dunes which have been deposited
Actually,
in the desert.
she is asking whether the aeolian and glacier, their erosion and deposition features and their formation are enough. Means what is the extent of teaching this geomorphology for aeolian and glacial deposits?
That much is enough.
Yes.
Which is
I
I
think also that much is enough, because preliminary work we have to understand there. And for this geomorphology of aeolian and glacier, what is the basics of what is mean by the aeolian process and what is mean by the glacial process? This you have to be, students have to understand, and then they must have understood these topics in the three way we can say. The first one is the erosion. So how the erosion is generated? The erosion is done by what type of activities? In case of wind, we can say desert. We can say the aeolian activity or aeolian erosion is done by blowaway action. The aeolian erosion is done by abrasion. The attrition is there. No hydrolysis or no, we can say, solution activities there in the desert area. So these basics have to be understood by the student. Erosion, how it is generated. Then what are the landforms of erosional activity? And again, the landforms of the depositional activity. These are, I think, sufficient for them. Erosional and depositional, right from both the cases. Right, in case of even the glacier also. So how the glacial erosion is generated? What are the process of erosion? Erosion done by plucking action, erosion done by the abrasion, erosion of the valley cutting, and so on. This then landforms of the erosional activity and even landforms created because of the depositional activity. I think this is sufficient, sir.
Yes.
Okay. Yes, sir. That's it. There are no more questions from the participants. So,
yeah, thank you.
Yes, sir. Aswar, sir, please.
Thank you, sir. I express my deepest sense of gratitude towards our speaker and the expert, Dr. Doke sir and Dr. Baba sir, for their valuable guidance for this particular session. We are thankful to you, sir, from our deep depth of our heart. Thank you very much, sir, once again.
Thank you.
Thank you.
Yeah. There's one announcement for the participants. We are beginning with the session, next session at sharply at 1:30. So please be present there for the next session at 1:30. Thank you, everybody, sir.
Yes, sir. And I just want to add one more thing, that this third session will be having a different login ID and password, and which is already shared on the WhatsApp group. So
yeah, please log in with.
Please follow that link.
Yeah.
Yes, sir. Thank you once again, all the participants. Lokesh, sir.
Yes, sir.
Thank you, Doke sir. Thank you, Babar
Thank
sir.
you. Okay, thank you, sir. Thank you.
Thank you,
Thank you, Pankaj sir, and thank you, Shirke sir. Okay. So nice. Wonderful introduction.
Yeah.
Thank you.
Sorry for some disturbances from our side. Actually, we got some internet connectivity issues. So sorry for that interruption what has occurred earlier.
Well, let's meet at 1:30. Chalo.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
Yeah.
Okay. Thank you. Hade sir, thank you.